Today we're going to be talking about 6.6 rational numbers. So the definition of a rational number is any number that can be written in a fraction form. So even if it doesn't look like it's in a fraction, if you can put it into a fraction form and it can still mean the same exact thing, then that is a rational number. Okay, so the definitions here for number one, or the instructions say, show that the number is rational by writing it in A over B form. A over B form simply means you need to have a numerator and a denominator. That's all it means, okay? So let's look at problem A. It says 6. Is there any way that we can turn that into A over B form or into a fraction form without changing that it means that it's a 6? Yes. 6 over 1 means the same exact thing. Let's look at B. Does that look like it's already in fraction form? It does, okay? But here's the one thing that is not correct if you want something to be a rational number or an A over B form. Do you see that that says negative right there? You've got to attach that negative to either your numerator or your denominator. So it needs to be specifically negative 4 over 7, or if I didn't attach it to the 4, what would the other one say? 4 over negative 7. No matter what, you just have to attach that negative sign right there to a number, and then that is put into rational form. Problem C says 0.6. How can I make that look like a fraction, Asia? 6 over 10, okay? Because this right here is actually in the tenths place, then we know that means 6 over 10. Can 6/10 be reduced at all?
Yes.
To what?
3/5.
3/5, because a 2 can go into both the numerator and the denominator. So your correct answer is 3/5 or 6/10 if it's not reduced. Last one, problem D. Does that look like a fraction? No, what's that called? It's a mixed number, but I want it to look like a fraction. So what do I have to do to it, Carlos? Okay, we make it improper, so we're going to multiply those, and then we're going to add those. When you do that, what do you get? 14 over 5, but what do I have to do with my negative?
You have to attach it.
Attach it, okay? So it could be negative 14 over 5, or what, guys?
Negative 14 over negative 5.
14 over negative 5. Notice you did not switch where the numbers were. You simply just changed where the negative sign went. All right, so that is how you put something into A over B form to show that all of those numbers there were rational numbers. Today I'm going to talk to you about 4 different kinds of number properties. The first one we're going to look at is commutative properties, okay? So the yellow sheet that I handed out to you is something that you're going to want to kind of learn and understand what these properties are. The first one that I want you to think about, commutative. How many of you guys have ever heard the word where someone says, I have a long commute to work, or I have a short commute to work? What does that word commute mean? What do you think? What is it? A period of time? Not necessarily. What do you do in a car?
Drive.
You drive, okay? You're driving a car, you're moving around, okay? You're changing where you are, okay? When you are at home, then you have to drive to school or you commute to school, okay? You're moving around, all right? So today we're going to talk about commutative properties, and when you think about this, I want you to think about one key word for me, okay? The key word is going to be the word order. All of these properties that we're talking about, there's going to be a property for addition and a property for multiplication. These properties do not work for subtracting or for dividing, okay? So the main thing is the first one, commutative property of addition. It says you can add the numbers in any order and it will not change your answer. So this first part that we have here, what does that say? 4 plus 3 is 7. Let's switch the order of those first two numbers, and instead, what does this say?
3 plus 4 equals 7.
Did that change our answer? No. So what the commutative property of addition is saying, you can switch the order of the numbers that are there, and it's not going to change what your answer is. Pretty simple, yes? Okay, let's look at the next one. The commutative property of multiplication. The difference is here, now we're talking about when we multiply numbers, okay? You can change and multiply numbers in any order and it will not change your answer. So you can look right here at this first car that I have here. It's taking a commute. It's saying 3 times 4. What does 3 times 4 equal? 12, okay? Or you could switch the order of those numbers, and what would those be? 4 times 3. It does not matter what order you get, no matter what, you're supposed to get the same exact answer. And that is what the commutative property tells you. The next one is the associative property. How many of you guys have ever heard someone say something about who you associate yourself with? What does that mean?
It means like who you hang out with, like who your friends are.
Okay, who you hang out with or who your friends are, okay? Who your group of people is that you hang out with, all right? So, key word here for associative property is grouping, all right? What I want you to do is go ahead next to your notes where you see associative property. I want you to go ahead and draw a picture of you and your best friends in a group together. What does the associative property of addition say? Changing the grouping.
Doesn't change the answer.
Okay, so I want you to look at this right here. This is a group. Do you guys remember what we have to do with parentheses? Do we do them first or last?
First.
Every time you ever see parentheses, you do them first. What is 3 plus 4? 7. Then I'm just going to keep going. What is 7 plus 5? 12. All right, let's come over here. Notice, this one right here said 3 plus 4 plus 5. This still says 3 plus 4 plus 5. The only difference is I didn't change the order of the numbers. I simply changed where I grouped them together. How do we group in math? What do we do? You put parentheses, okay? So let's do the parentheses first. What is 4 plus 5?
9.
9, and then I still have to add the 3. What's 3 plus 9? 12. Notice, it did not matter how I grouped them and what I added together first. My answer still stayed the same, okay? So remember, associative property, it's how you group the numbers together. Read me the associative property of multiplication.
Changing the fact that doesn't change the answer.
All right, this means the same thing as that multiply, or with the adding that I just did. Let's go ahead and do this. What's 3 times 4? 12. Okay, what's 12 times 5? 60. Now, this said right here, 3 times 4 times 5. This also says 3 times 4 times 5. But I have to do my parentheses first. What is 4 times 5?
20.
20. What is 3 times 20? 60. Is that the same answer?
Yes.
So once again, the associative property says it doesn't matter how you group them, you're still going to get the same exact answer. All right, the key word for inverse is opposite. That's why I have happy face and a sad face here emoji on our notes. The inverse property of addition. The sum of a number and its opposite, which is called the additive inverse. Everyone say additive inverse.
Additive inverse.
Let's just break this word down so it doesn't seem quite as scary as it might sound. Whenever you hear the word additive, what do you think you're doing?
Adding.
You're adding, okay? Now, inverse, what was the key word I just told you means inverse? Opposites. So you're just adding the opposite. So let's look at this right here. 10 plus negative 10. What does that equal? 0. 5 plus negative 5.
0.
7 plus negative 7. Do you guys remember? It's a 0. A number and its opposite always equals what?
0.
That's all the inverse property is telling you. A number and its opposite always equals 0. Now, there's something a little bit different whenever we are talking about the inverse property of multiplication. Read me what this says about the inverse property of multiplication. The product of a non-zero number and its reciprocal multiplicative inverse is 1. Now, once again, you might look at this big word, multiplicative inverse, and think, oh my goodness, what does that mean? Let's break it down. What do you think multiplicative means? Multiplying. And what does inverse mean? Opposite. When you're multiplying an opposite number, this is what the opposite is. Do you guys remember a reciprocal? All you have to do is what? Flip it, okay? So 9/20ths, the reciprocal would be 29ths. Can I simplify this? What would that be? A 1. Can I simplify this? Yes. 1 over 1 times 1 over 1 equals 1. So all we have here, the inverse property tells us that if you multiply a number and its reciprocal, you will always get the answer 1. Okay, so the next one is identity properties. What do you think about when you think about your identity? Can anyone tell me what you think that means? You as a person, your identity.
Like, it makes me think of kind of like the government and knowing like our fingerprint and like exactly who we are.
Okay, your identity is who you are, all right? So right here, I have a mirror. Whenever I look in this mirror, who do I see?
Yourself.
I see myself. When Michael looks in the mirror, who does he see?
Myself.
He sees himself. If you think about a mirror, whenever you see a mirror, you see yourself. So think about a mirror when we're talking about the identity properties. This right here says the identity property of addition. So notice I've got two different ones, an identity property for addition and another one for when I multiply numbers together. So what this tells me is the sum of a number and 0, which is the additive identity, that's a word you're going to want to memorize and think about, is always the number itself. So that might sound complicated, but let's just look at the example that I've written here, okay? -7 plus 0 equals -7. It equals itself. Let's say that I have 5 plus 0. What does it equal? 5. It equals itself. Think about the number 5 looking into a mirror. It's going to see itself, all right? Let's say I've got the number 22 plus 0. What does it equal?
22.
It equals itself. Always just know, whenever you have the identity property, it simply means if you add 0 to a number, it doesn't change the number. It's still going to equal itself. Does that make sense?
Yes, ma'am.
Okay, next up, identity property of multiplication. If I multiply something by a 0, what do I get?
That number.
I get a 0, okay? So notice this rule is actually different. It says the product of a number and 1, which is the multiplicative identity, is the number itself. So for this one, don't try to multiply it times a 0. You're multiplying it times 1. Notice my example that I have right here. 9 times 1 equals 9, which is itself. 10 times 1 equals 10, which is itself. 31 times 1 equals 31, which is itself. So all the identity property says, if you add 0 to a number, you get itself. If you multiply 1 times a number, you get itself. So all of that to say, that's a lot of information, but I want you to go ahead and write down these shortcuts. These are little words that are going to help you remember which number property you need to use. These shortcuts are something that you're going to want to memorize so that you can easily understand how you can move numbers around or do certain things to different numbers. So the thing that you want to remember for commutative property is the order. Think about a car. A car moves around. You can switch the order of numbers, and that has to do with a commutative property. The associative property has to do with grouping numbers. If you're ever grouping numbers, it's going to put them inside of parentheses. So make sure you see, unless it has some kind of parentheses with an operation in the middle of it, it's not going to be the associative property. Next up is the inverse property. Just remember, it all has to do with opposites. Memorize these shortcuts. And the final one, the identity property, is a mirror. When you look inside of a mirror, you see yourself. These numbers, if you are adding a 0 or if you're multiplying by 1, they are still going to get themselves according to the identity property. So that was a lot of information, but all of that information is going to help you on this assignment that we're doing today and then also on your homework tonight. So this one right here says, evaluate the expression and justify each step that you take. What does evaluate mean? Solve it. Okay, so we're going to come up with what an answer is, and then we're going to justify or explain why we did what we did each step. Okay, looking at these right here, is there anything that you think I could switch around that might put some numbers close together that would make sense for me to do? What do you think we should move around?
-4.4.
Okay, let's move that negative. Why would we want to move the negative?
Because there's two negatives. And you want to solve them first.
There's two negatives there, okay? So we've learned all about same sign, add and keep, different signs, subtract and take. It would help us if we just simply moved around that 4.4 and we switched the order of 4.4, or the negative 4.4, and the positive 3. Now what I have done is I have grouped them together. Which property did we learn about that told us we're allowed to switch the order of our numbers? Commutative property. Remember, think of it like a car. A car commutes and moves things around. The commutative property tells us we're allowed to change the order of our numbers and it will not change our answer. Now that you see this, is there any kind of numbers that are similar, which we just talked about, that I could group together? Both the negatives, okay? Now, would it make sense for me to take my two negative numbers and I've got here parentheses to put big parentheses around it? Doesn't that look kind of funny?
No.
So there's something else you can do. Instead of putting big monster parentheses, you can put a bracket. A bracket is simply another way to write parentheses. The only time that you really would use a bracket is whenever you've already got parentheses and it's going a parenthesis right next to a bracket, okay? So that's just showing me I'm grouping my negatives together and I still have to bring down my positive 3. When I group numbers together like that, which property tells me it's okay to group them together? The associative. Okay, think about it. When you associate with your friends, that's your group of friends. So that is the associative property that tells us it is okay to group numbers together, and it's not going to change your answer. So let's go ahead and look at this right now. What is negative 10.6 plus negative 4.4?
15.0.
Okay, she says 15.0, which is the same thing as 15, but is that correct, guys?
It's negative.
It's negative. Same sign, add the numbers, keep the sign, all right? Do I have to bring anything else down?
No. The positive.
I got to bring down the plus 3, okay? Now, this is just a normal problem that we would do right here, so you don't have to justify the step you take because we're simply going to be adding and subtracting the numbers together. What is negative 15 plus 3?
Negative 12.
Same sign, add and keep, different signs, subtract and take.
Negative 12.
Negative 12 is correct. Go ahead and box your answer in, and now you have evaluated the expression. All right, the last one we did was with adding. This one is going to be with multiplying. Same kind of rules apply. Is there anything here that I could move around that would make sense? What should I move around? Let's move the negative 4. We're going to switch the order with the positive 7. Okay, why would you switch the order there?
Because they're both negative.
Okay, you're putting negatives together. So when you switch the order of your numbers, what is that called, class? Commutative property, because you switched the order. So go ahead, justify your step and why you took it. That is the commutative property that allows us to do that. All right, just like the last problem, there's something here that's similar that we can group together. What is it? Okay, the 25 and the 4, why are they similar? They're both negatives, okay? So just as Michael had just mentioned, we're going to go ahead and put brackets around it to group it together and bring down that 7. Which one of our properties told us it is okay to group numbers together and it's not going to change your answer? What was it? Associative property says that we can do that. All right, so let's go ahead and do this first step together right here. What is negative 25 times negative 4? Okay, I hear negative 100 and positive 100. Because there's two negatives, when you multiply, they become a positive answer. So this is 100, and then I'm going to multiply it times 7. What is 100 times 7?
700.
700 is your answer. Okay, we didn't really use any of our properties to do 100 times 7, so you don't have to justify the step that you took. All right, it tells us here the inverse property is always followed by the identity property. How many of you guys have a best friend? Okay, maybe someone you sit with at lunch. How many of you would say your best friend is here at this school? Okay, who has one outside of the school? All right. Think about these two right here like best friends. They are always together, all right? So if you see the inverse property, it will always have the identity property right after it. So let's go ahead and talk about some ways that we can figure out and justify what we're doing for this problem. It says 2/3 plus 7/10 plus negative 2/3. I want to move some numbers around to put similar numbers next to each other. Can you guys think about what up here looks similar to something else?
The 2/3 and negative 2/3.
The 2/3 and the negative 2/3 definitely look similar. So I'm going to go ahead and switch the order of those so that they can be closer to each other.
You got to put the negative sign in one of the numbers.
Okay? So we found something, a reason why we could move them or change the order. JD, what tells me I'm allowed to change the order?
Inverse.
Not the inverse. Look at your clue words. Look up here on the board. Look in your notes. Which one is it? Nope, it's not the identity. I want you to look at the key words. Which one says I can switch the order around? Yes, commutative property. Okay, think about a car. You move around in a car. Commutative property means you are allowed to move the numbers around. Now, what can I do with this 2/3 and negative 2/3? What are those?
Fractions.
They are fractions. They are integer. Well, it's not integers. Integers are whole numbers. That's a number and it's what?
Opposite.
Opposite. Remember how we talked about before? 5. What's the opposite of 5?
-5.
Negative 5. What's the opposite of 10?
-10.
Okay, so what do you think the opposite of 2/3 is?
-2/3.
Negative 2/3. What happens to a number and its opposite? What's 5 plus negative 5?
0.
0. What's 10 plus negative 10? What's 2/3 plus negative 2/3? 0. So simply when you're looking at this, you can basically cross that out and that equals 0. So I still got to bring down plus 7/10. Which one of my properties told me that a number and its opposite always equals 0? Inverse property is correct, okay? Once again, you've got to justify the step that you took. Looking at this, 0 plus 7/10. What's my answer?
7/10.
7/10. Now, I'm going to box this in because that's my final answer. But guys, he told me it's 7/10. But what did he do with the 0?
Nothing, because it was just a 0. You just leave it out.
He just let it go. Do you guys remember what the identity property told us?
Yeah,
It said that you can add 0 to any number and it will not change the identity of the number. So guys, which property told me I could do that step?
identity.
The identity property. Now, remember the note that we just wrote ourselves up at the top of our notes? Where we said the inverse and the identity are best friends and the identity will always follow the inverse, no matter what. Okay? So that is how you do a problem that has identity and inverse properties. Let's look at this next problem. 1/4 minus 7/8 minus 1/4. Kyla, what do you think I should do first?
You should move the number like 1/4 and 1/4. That 1/4 closer to the other.
Okay, we want to move the numbers around so that we can put numbers that are similar to each other next to each other. So I think that's a great idea. She says, let's go ahead and move this 1/4 and trade places with that 7/8. So we're still going to take the sign directly in front of it, okay? So we've got minus 1/4, and then the next one would be minus 7/8. Jakari, which property told me I was allowed to move my numbers around? The commutative property, just like a car moves around, remember that picture that we had, you can move around your numbers and change the order and it will not change your answer. Next up, is there something I can help simplify this problem right here? Michael.
Because the 1/4 and 1/4, they are opposites.
You are correct.
So
1/4
then-
and negative 1/4 are opposites.
So then what you want to do, you just cross it out because it makes it equal 0.
It does equal 0. And I still have to bring down my minus sign and my 7/8.
And then it's 7/8 because 0 is 0.
Okay? Help me out, Emma. Which property told me that a number and its opposite always equals 0?
Inverse.
The inverse property. Good job. Because remember, our keyword for inverse is opposites. Think about that happy face and that sad face. Now, let's figure out what our answer is. Asia, what do you think the answer is? Okay, she says 7/8. What do you think, guys?
Yeah, true.
Every number has a sign. Where's the sign? Directly in front of it. Okay, so you've got to still take that sign with you and bring that down. So your answer is negative 7/8. But once again, we have just chosen to simply get rid of that 0. Which one of our properties told us that if you add or subtract a 0, it does not change your answer? It is the identity property that tells us we're allowed to do that. Once again, remember, identity will always follow the inverse. All right, this is tonight's homework for you. Once again, spend a couple minutes trying to memorize the shortcuts so that you know the special clue words that will help you understand which property it is that you're using.